Hey Stats class, I'm here on a Saturday morning recording your lesson for this week. And we're starting in chapter 6, and chapter 6 is on finding the area under a standard normal curve. So we've dealt with bell curves before, and we understand this whole idea of the mean, okay? We're using mu now instead of x bar like we did in chapter 3. But regardless, this is still the mean, okay? We still have 1, 2, 3 standard deviations to the right of the mean, and we have 1, 2, and 3 deviations that fall below the mean. So in this chapter, what we're going to start looking at is, suppose I had a standard deviation of 2. I want to figure out what space is filled to the left of this standard deviation. How much room, area, is under this curve? So you're going to be introduced to something called a z-table. Mrs. Griggs will give that to you, as well as the notes for this chapter. Before we begin with finding the area, we have to understand something about z-scores first. So a z-score is the equivalent of the exact number of standard deviations a specific value is, okay? So in this case, if I had a z-score equal to -2, that would just mean that I'm exactly 2 standard deviations away from the mean, okay? So I'm going to give you a formula to find a z-score, and then eventually we'll get to the point where we're finding the area under a curve for those specific z-scores. So in your notes, you'll see something about a standardized variable. Well, a standardized variable is the same thing as a z-score. So a z-score is equivalent to a standardized variable. Okay. So suppose someone's IQ is 120. And we want to find where they fall on the normal bell curve, and we want to find out specifically exactly how many deviations they are from the mean. That's the same as finding a z-score. So, what do we need to know? In order to find this z-score, I need to know the mean. All right, so suppose someone's IQ score is 120. Well, the average or mean score of an IQ is 100. That's a given. I didn't make it up. Also, the normal standard deviation between those scores is 15. Okay, so if I was on a regular normal bell curve, it would look something like this. Okay, so if I set up what a normal curve looks like, And where did these values come from? Well, this is my mean. And to get one deviation above the mean, I just added the standard deviation, which is 15. Okay, but my question wants to know is how many deviations exactly is 120 away from that? So 120 falls somewhere in here. So it's not 1 and it's not 2, but it's somewhere in between 1 and 2. So how do we go about finding exactly what that is? Well, we have this thing that we use to figure a z-score. Okay? And we're going to use x minus mu over lowercase sigma. Okay? In language, in English, that just means I'm going to take whatever test value I'm given. In this case, it's this 120. I'm going to subtract the mean, and I'm going to divide by the standard deviation. So, here goes. To get my z-score, I'm going to use 120 as my test value. I'm going to subtract the mean, which is 100. And I'm going to divide that by 15. So 120 minus 100 is 20. So to get this z-score, I'm going to end up dividing 20 by 15. Now, of course, let me grab my calculator. 20 divided by 15 is 1.333. So, this is plus 1, this is plus 2. It's a little bit more than 1. So it does make sense that the number of exact deviations this is from the mean is 1.33. Okay, let's look at an example of an IQ that's below the mean. So we'll change this, and this will change, and then this will change. Okay, so suppose I have a person whose IQ is below the mean. So let's say their IQ is 77. Okay, 77 is somewhere around here. Here I'm at minus 1, here I'm at minus 2 deviations. So this is going to be somewhere in between those. So again, to find a z-score, I'm going to take my test value, which in this case is 77. I'm going to subtract the mean. I'm going to divide by the standard deviation. So let's see what I get. 77 minus 100. Okay, if you're doing this on your calculator, make sure that you get an answer. 77 minus 100, enter. Then divide by 15. Okay, if you don't key it in correctly, you're going to get the wrong answer. And this gives me minus 1.533. Is this about 1.5 deviations below the mean? Yep. So the z-score, again, represents the exact number of deviations something is from the mean. All right, so big deal. We know the number of deviations, but now we have to find the area. Like, how much space under my curve is all of this? Or in the previous example, from here, how much of this space is being filled up? Well, how do you figure that out? Well, first of all, we're going to get what's called a z-table. Okay? And your z-table has two parts to it. There is a negative part to it, and there's a positive part to it. And so I'll show you how you figure out how to read these bad boys. First, I'm going to do some calculations and show you exactly what this means and how you go about doing it. So, probably, first I'll illustrate and show you where these points are on our graph. going to take first this standard deviation, or z-score, of 2.24. It's important to remember that when you read the z-table, you're always finding the area to the left of that score. So 2.24 is probably about right here. So what I'm looking to find is this area. All of this space. To do that, I'm going to use the z-table. I have to erase this because I really want to shine something up on the board. I want to shine that z-table up there so you can see what's happening. So I'm going to erase this. Extra information. In one of the homework assignments, practice problems where you're finding z-scores. I just want you to look at number 3, and it gives you a table. The table consists of things like clerical ability, logical reasoning, mechanical reasoning, spatial relations, and verbal fluency. So what it wants you to do is it wants you to take each of these scores and convert them to a z-score. So let's look at clerical ability. It tells you that the mean is 50. The standard deviation is 15. The score, which is our test value, is 41. So, to figure out my z-score, let's remember, I'm going to take my test value minus the mean, and I'm going to divide by the standard deviation. Okay? Easy peasy. So my z-score, I'm going to take my test score, 41. I'm going to subtract the mean of 50. I'm going to divide by the standard deviation of 15. Okay? So it's very important, once again, do what's on top of this fraction first, 41 minus 50, get an answer, and then divide by 15, and we get a negative 0.600. Okay? So again, things should be logical, things should make sense. Okay? If I scored 41 and the average is 50, clearly I'm below average. Does my z-score represent below average? Absolutely, because on the curve, I'm 0.6 deviations below the mean. Okay? So, on this homework assignment, you're going to do the problems on page 1 and page 2. On page 2, there's a lot of tables. Okay? It just makes it easier to organize your stuff. Okay, do your work on separate paper. It asks you for the best and the worst cases from each of the tables. I think that's self-explanatory. All right, so what I'm interested in you doing is page 1 and page 2 of this packet. And we're not going to do anything with the null hypothesis just yet, and that's what's included on the other pages. So for right now, just focus on doing those z-scores and getting the